I am Jason Bell, and this is my senior portfolio critique. All right, so who am I? As you all know, I'm a soon-to-be graduating senior here from Barry, a degree in creative technologies. In my time here, I've tried to dip my toe and get my hands dirty in just about everything, from metalworking to working with acrylic, laser cutting, and specific types of foam. Sewing. In my time, I also ran here for a period of time, and I continue to run. And then this is me with the gang going and hunting a atmospheric probe in a cornfield. So in my time here, while I've put my hand in pretty much everything, I've found three distinct passions of mine. The first of which is 3D design and 3D modeling, which you can see. I have all three of my major knife projects all modeled here, as well as Mighty Mouse. PCB design is something that I really found, and that's actually going to inspire a career in the future. And then 3D printing as well. That came first, and it's still probably my favorite thing. My printer is my baby. So my theme for my critique is designing form-first PCB-based technologies. So what that means is we normally think of PCBs as this green square or whatever shape that electronics will go on, and it'll get slapped inside of a container or a housing, and you'll never see it again. My thinking is, why do we need the housing? Why can't we just use the PCB and have all of the information and have the PCB actually be its own separate or its own singular device without the need for any other containment housing? So my first project brings us back to our high altitude weather probe, our high altitude data probe called the HACK probe. As I said, it's a high altitude data collection device. It had several design constraints. We wanted to fit with a 100 by 100 by 100 millimeter diameter or dimensions. We got very close. We fit the 100 by 100 length and width, but in terms of height, we went a little bit over. We wanted a target weight of 1 kilogram. I believe we actually doubled it initially and then walked it down to about 1.5 kilograms, which that's pretty close. And we probably went way overkill with the battery anyway. And we also wanted the PCBs to serve as the main structure of the device itself. So you see here the Hackberry logo and our unicorn. That's actually just insulation. That provides no structure whatsoever. This is also my very first PCB project. So Hack Probe consisted of a stack of 8 PCBs all working together. They weren't all stacked like directly on top of each other. We used, I believe, 12 millimeter standoffs to create spacing in between to allow for electrical components to be placed in. And we also, my responsibilities were the first layer, which this was the bottom layer. It had all of our exterior atmospheric and luminosity sensors. It also had an opening for our bottom-facing GoPro to catch video. So the camera, and then in layer 1, there was a hole cut to house the body of the camera. This really got really stimulated my brain and how I wanted thinking of, oh, this layer actually has no electrical significance other than it holds the body of the camera, which matches up with this nice opening so the camera could actually see down towards the ground as it was flying up. So then there are these holes that go around the perimeter. These are our data buses, so they allow for us to wire up a connector, and then you run the wire all the way up to the main center control panel or control PCB, which had our microcontroller, which collected and wrote all of our data for us to collect and analyze at a later time. So this brings me to our next project. This is my third PCB project. So I've had a little bit more experience. So this is a handheld gaming device that I made in advance. There were 2 different schools of thought of the Nintendo Switch style and the Game Boy style. I would, as you can see, with the Nintendo Switch style, it came down to comfort. So I spent lots of hours kind of going through with foam core, working on the spacing of the buttons, the screen, and the joystick. And also working on just getting those angles just right so you can hold it in your hands and play for the incredible game hunt for Dr. Z for hours and hours on end. It's actually worked out very well. I'm very pleased with this project, and it really helped me think for the next 2 projects that I have. So that brings me to a third project. Lightwave, it is an educational device used for teaching in the electromagnetic spectrum. So I wanted to fit, again, with the 100 by 100 design or size. I felt that was comfortable, and if this is going to be used to teach children, I felt that was comfortable, and not only in my hands, but someone who's smaller than me's hands, or someone who has bigger hands than me. So as I said, it's designed to teach kids about the visible light along the electromagnetic spectrum. So as I said, it is designed to be handheld, and all of the components are placed as such to facilitate this comfortable holding, so you can complete this educational experience. So the text and images on the PCB itself also help walk you through the experience that this device is meant to help with. So you start by moving your slider through the visible light wave spectrum, which is a silkscreen just wave, which represents that you have the tighter, shorter wavelengths at 450 nanometers, and you have the longer at 700 nanometers. Not to scale, obviously. It's just a visual representation. And then after you move that, you move up, you then push your test button. It will spit out whatever wavelength you put it at, and it will give you the color that is represented by that. So a kid will approach something, will follow through, will like approach, I don't know, a blue wall, and they'll look at this wall and they'll be like, all right, cool. They'll take the background information that they have, they'll slide through, they'll test it, they'll figure out if they were right or if they were wrong. And if they were wrong, they can make an educated guess on where they need to go in order to get blue and figure out what wavelength is blue. So all of these projects lead me into my capstone project, which I call the LED evaluation device, or LED. So this was my innovation capstone. It's designed to test commonly used LEDs. So for my design constraints, I wanted it to be handheld or wall mountable, interchangeable. I wanted you to be able to plug it in and leave it on your desk or mount it to a wall, and it could stay there. Or I wanted you to be able to unplug it, run it on battery power, walk around and test LEDs if you need it. I also wanted to test common LEDs that we use in the lab. So all of the LEDs that are on here, except for the common anode, I've actually used multiple times while in here, and I've actually not seen anyone else use any other LEDs, but I haven't been here all that often. I also wanted to max out my @tiny. I didn't want to go overkill on a giant microcontroller, so I had to do some intuitive thinking on how to get everything I wanted on the PCB and powered by one microcontroller. So this is all of the LEDs that it tests. Over on the far side, we have a NeoPixel strip. Next to that, we have a surface mount WS2812 NeoPixel. In the top row, we have a through-hole WS2812 NeoPixel, a 2-pin LED, I don't quite know the name, a VO603 surface mount LED that we use on the business cards. We have the common anode and common cathode variety of the RGB LED. All right, so where's the innovation now? This is a really cool project, but cool. Everything, you could do some of these things with just through-hole mounts, which is what I did. So, like I said earlier, I maxed out an @tiny 85. @tiny 85 only has 8 pins. One of those is the reset pin, which I did not use. There are 8 components on here. That means some things needed, and the RGB LEDs actually needed 3 pins by itself. So that meant I had to do some intuitive thinking on how to get everything to run together. So there are several things that actually share pins, and they still get the job done just as well. I also wanted to do, so my final design requirement that was the most important that I wanted to hit first and foremost is I wanted a solderless tester. I wanted you to be able to take an LED out of the bag or box and plug it in and have it just work. There are no soldering jigs, no soldering wires, anything. It just worked. So there are two LEDs that don't necessarily fit that criteria. A strip neopixel, the only way to test that is to either use alligator clips or solder wires to it and then plug it into Arduino and have it do that. And then the surface mount neopixel. So in order to facilitate both of these things, I first created this 2-stack PCB design. The top stack has all of the testers minus the surface mount WS2812 neopixel. All right, so for testing these two, the actual design of the surface mount WS2812 neopixel, it's not just a flat contact that's just on the bottom. The contacts go up the sides. In order to get a good copper connection, you need to have copper coming up. You need to have a solder contact that goes up the side. So there is a hole in the top PCB, as seen here, that corresponds with this footprint. When I put solder in there, when I put solder on the pads, you can drop your surface mount LED or surface mount neopixel into the hole, push it down, push your test button, and it works because the contact comes up and it grabs the sides as well as the bottom. So it gives you a nice strong connection. So for your strip neopixel as well, you could solder it, but why waste the time? Why don't you just want to pull it out of I just want to pull it out of the box and test it right immediately. I don't want to have to do all this fancy soldering. This went through several design iterations. I landed on using a 1 centimeter ribbon cable, 20-pin ribbon cable connector with several of the pins blocked off for power, data, and ground. So when you plug in your strip neopixels, they work as well. All right, so the future for me, coming up here in May, I will be embarking on a CRT 350 study abroad to Norway, where I will be taking Lightwave to go teach children about the electromagnetic spectrum. Following that, I'm currently working for the Atlanta Braves on their game day grounds crew, so I'm taking care of their grass. That started in April and it will go till October until we lose, which hopefully we win the World Series game. So where does that leave me? In the time, I'm not just working for the Braves, just kind of sitting on my butt, not doing anything. I'm currently looking for jobs, possible fields, like I said at the beginning. 3D printing is something that I love, and if I end up in a job working in 3D printing, I won't feel bad and I'll feel accomplished with my life. Similar with 3D design and modeling, that's something that really brought on a late charge in the last about year. Something that I really enjoy. I really find taking things that I have in my hand. So everything I've modeled are tools that I have. So I have 2 pocket knives and my multi-tool. Those are things that are sentimental because of who got them for me and when, but also I use their utility. I use them a lot and they're really nice just to have a really nice model, as well using them for holders, or like I'm making something, a custom holder for my multi-tool that actually fits on my belt because the Leatherman ones suck. And then PCB design, as you can kind of see through my theme, PCBs, I like to think outside the box. PCBs have this tendency of just, it's just throwaway technology that we just, we think about and use. Why? My thinking is, why can't it be in the forefront? Like, it's just something that's fun and it makes things simpler, it brings costs down, and I enjoy it a lot. And if I get a job in PCB design, life accomplished, I'll be happy. And I'd like to thank you all for coming out. Are there any questions?